Section 8.3 in the Red Stewart textbook, we're talking about logarithmic functions. And specifically, we're talking about logarithmic functions that are connected with the exponential function that has a base of e. So there's a special log function that we're going to talk about today and we're going to learn about. But first of all, let's cover some ground here, some review ground. Did you know that the logarithm is the inverse of an exponent or an exponential function? So let's take a look at this. Y equals anything, like y equals b to the power of x here. Let's not make it e for now. Y equals b to the power of x. Let's make it instead 10, okay? Y equals 10 to the power of x. So watch this carefully. You guys pay attention? Watch this carefully. If you flip these around, so if I go x equals 10 to the power of y, and I solve for y, do you remember how you solve for a variable that's in the exponent position? Do you remember mathematically, algebraically, how we would do that? Well, you can't just bring it down until first of all you do what? You use the log. So if we did this, and again, I'm just trying to squeeze this in here, but I'm going to change my color to black, and oh boy, I got to find a spot for this. I've got all this stuff laid out, now I've changed what I was going to do. So if we just move some of this down, that's terrible. I'll keep going over here. So look at this. Log of x equals log of 10 to the power of y. Well, if I do that, now y can come down. So notice how I'm doing this. Y equals log of x over log of 10. Okay? Now log of 10 base 10 is actually 1. So I have y equals log x. So if I had y equals 10 to the power of x, the inverse function is y equals log. So an exponential function with base b has an inverse function, inverse, reverse, the x and y, has an inverse function of log base b. Okay? So now let's think about that in terms of our e. So I'm going to erase all this now. Okay? So you're going to see this at the corner here. Y equals e to the power of x, okay? So here is y equals e to the power of x. That's this function right here. It's an exponential function, has a base e. We learned about that yesterday. So if I were to graph the inverse, the function would be what? Y equals log of what? Log of x base e. Okay? Log of x base e. So that is a true fact that we should know about. You should know about this from math before, but we just want to review that. Now, log base e, because e is so special in calculus, the inverse of e is very special in calculus as well. It is called the natural logarithm. So log of x base e is called the natural logarithm, and the n and the l constitute the short form for this log, and it's actually ln of x. From the Latin logarithmus naturalis, I believe, but that's where ln comes from. That's why it's not nl. And so down here, I have this highlighted. It's not an I, sorry. ln x is the natural logarithm of x. That equals log of x base e. Okay? All right. So the inverse function of an exponential function is a log function. The inverse of y equals e to the x is y equal ln to the x. Okay. Okay, we got that now. Now I did this last night. Whoa, Nelly. So I just kind of drew this. Now I don't want to confuse you, but I was thinking about this, and this shows up. This shows up a little bit in the course and in calculus. So bear with me. Watch this. Ln of x equals y, okay? So we have a function y equals ln of x. Now that is the exact same function as this. Do you know why? That's the same function as that. Now that looks funny because we haven't isolated for y. But these are the same. These are equal. And that's because, remember, this natural logarithm, okay, that's log of x base e equals y. And remember how I turned this into an exponential. I look at the base, which is e, and I take it to the power of this, y, and that equals x. So that's where I get this from. Okay, so those are the same graph. Now watch this. This is kind of cool. If these are the same, if you just go ahead and switch x and y and say y equals e to the power of x, that's now the inverse function. Okay, so these equal each other, and these over here, I guess this one and this one are inverse. Because here's something that's equal to the original one, and now I've switched x and y, they're inverse. So that's just another way to think about these graphs, okay? Now, I have to kind of check this out. I think I did this on, no, where did I go with this? Okay, so e to the power of, oh boy. Okay, I adjusted this for yesterday's lesson. Remember how we moved the k around to make it equal to ln of 6? So give me a second here. All right, so I have here, I'm going to get rid of this one in red. I have here in black here, y equals e to the x. Okay, that's y equals e to the x. I also have x equals e to the y. This one, this blue one, is x equals e to the y. They are inverse. We just flip them around. Okay, and so if I took away this one over here, and I also graphed, so this again, this is x equals e to the y, and if I did y equals ln of x, it's the exact same. So I think that confirms what I just talked about here. Those are the same, and these are inverses. All right, just want to double check that. So y equals e to the x, y equals ln of the x are inverses. Okay. All right, a couple other important notes. Ln of e equals 1. Why? Because ln of e is the same as log of e base e. So if like e to the power of 1 has to equal e to some power, and so that has to equal 1. So ln of e is 1. Also, ln of 1 is 0, because if you think about this, log of 1 base e, okay, e to what power has to equal 1? Well, e to the 0 equals 1, right? So, yeah, those two. Now, if you check your textbook out, I don't know if I have that. I don't think I have it written here. So I'll write this. Let's go back to your textbook over here. Where would that be? Are we read? Nope. Chapter 8. Here we are. There we are. Okay. Now, what do I want to go to here? I thought there's something that's very interesting in your textbook here that I want to highlight. Yeah, I think it's these ones here. Okay. Yeah, these ones here actually are a little tricky too. I want to make sure you understand this as well. It's going to be pretty small, but let's bring that in here. Okay, let's expand that up a bit here. Okay, a bit fuzzy, but so ln of e to the x is x. Why? Because log of e to the x base e, which is what ln is, equals x. That means e to the power of x equals e to the power of x. So this one, very important. Okay, ln of e to the x equals x. And this one here too follows that e to the power of ln of x equals x. So e to the power of ln of x, not ln of x equals x. Okay, so can I turn that into a log statement? Sure I can. E to the power of, so e to the power of ln of x, e is the base of the log, and e to the x, e to the ln of x equals x. So is this true? Yeah, it is, because log of x base e is the same as ln of x. Okay, so those are two important things, and you can refer back to that because it might not immediately jump out until you kind of learn that. That's kind of a subsidiary kind of thing. Okay, does anybody have any questions about anything you've learned so far here? Exponential inverse is log e exponential, e base, inverse natural log. That's log base e. Okay, so how are we going to do something like this? Here's an example. So solve e to the power of 3 minus 2x equals 4. Okay. Well, the exponent is in the, the variable is in the exponent position. So I'm going to have to use logs. I have a base e, so guess what? Probably be a good idea to use the natural logarithm if we have a base e. So you would probably do something like this. You go the natural logarithm of e to the power of 3 minus 2x equals the natural logarithm of 4. So what's the relationship between natural logarithm of something with base e? We just kind of learned about that. The natural logarithm of something base e is that something. That equals to. So the ln and base e kind of cancel each other out, almost. And this becomes 3 minus 2x equals ln 4. Now, how else could I have done that? What's the intermediate step I could have shown there? Well, you're saying, okay, now that I've done the logs, I can actually go 3 minus 2x times ln of e, right? Equals ln of 4. So you bring that down from the exponent position. No problem. Ln of e. What's log of e base e? 1. So it's just this times 1. Okay, does that help? Does that make sense? Am I going a little bit too fast here? All right. Look very confused if I'm going too fast. Ready?
How did?
Okay, I think I'm going too fast. Question.
How did you bring that down there?
Okay, so remember one of the really important properties of logarithms is if you have like 3 to the x equals 9, you know that one. That's easy. But you could also use logarithms. So you could use the natural logarithm, taking the natural logarithm of both sides. Now that you have a logarithm of a power, this exponent, this is equal to x times ln of 3. It's kind of like this exponent can come out of the exponent position and down as a regular coefficient. And that's what's really important about logs, because that helps us solve for variables in the exponent position, because we don't have like an algebraic way to do that without logs. So that's why logs are really helpful. So then this is what we have, and then x equals ln of 9 divided by ln of 3. Okay? So on 3 to the power, okay? So ln of 9 divided by ln of 3. Could do that. Let's say, I'm just going to double check here. So natural, here's the ln on your calculator. Ln of 9 divided by ln of 3 equals 2. So x equals 2, and that's, of course, the answer. All right, so we can use logs. Now I've got 3 minus ln of 4 equals 2x. Divide everything by 2, and now I have this. This is my solution. X equals 3 minus ln 4 over 2. And that's an exact answer. You can just leave it like that if you want, actually. Or you can evaluate that, and we can then double check to see if it's true. So what's 3 minus ln of 4? That's going to be this divided by 2. Okay, so here's my answer in a rough decimal form, 0.806. So let's put that answer into my original question here. Okay, let's put that over so you can see that. So let's go e. Where's e? You find e on your calculator. E, all right, to the power of 3 minus 2 times my previous answer. All right, e to the power of 3 minus 2x should equal 4.
Yeah.
We're good to go. Okay? So that's the exact answer, irrational there. Okay? Okay? Give me a nod if you understand that. Yes? Or a shake if you don't. With a weepy face. And if you actually cry, that's even better. Extra points. Can anyone actually cry about this? Okay. Not quite, eh? Too bad.
Okay.
All right.
I think I'm getting some of it, but I'm not getting totally yet.
Okay, well, I'll tell you what. Let's take a look. Remember the change of base formula? I'm not sure why I have this written down here. It was an example I did before. Anyways, I wouldn't worry about this. But remember, there's a change of base formula there as well. So let's take a look in our textbook. Where is that thing there? Here we go. And there's some examples in there that you can look at. It's just like some of the ones we did. There's a change of base formula, just a reminder there. So let's take a look at this yummy exercise right here. Wow, this looks great. Doesn't that look great?
Yummy is
I just said yummy, yeah. So remember, capital LOG, this log function on your calculator, LOG, that's the common logarithm, base 10, right? You know that. Okay. So let's see. For graph each function. Okay. We do need to understand, and this is a transformation thing from pre-calculus 30 that you guys have already learned. Do you remember what happens to the graph when you have this parameter inside the x? So something like this, ln of x plus 2 inside there. Do you remember what happens there? And do you remember what kind of transformation this represents? Did I remember all that?
One to the right, two to the bottom.
Okay, so if we look at D, let's look at D. So g of x is the natural log of x plus 2, and then plus 2 is inside the brackets. So yeah, that is a shift, a translation. Because it's x minus 2, that should be a shift 2 units to the left. If this is outside the brackets, that takes the whole function down. Okay? So yes, so that's transformations that you may or may not remember.
Inside the brackets is
Yeah, if you have if you have something inside the brackets here, that shifts. That's a phase shift, left, right. It's opposite of what this sign usually is. So let's just double check that here. Let's plot this on Desmos here. And actually, let's do that D that we were just talking about. Make sure we're correct. Okay, so I've got ln of x in red. I've got ln of x plus m. Now, if I move the slider to the right like it's a plus 2, look at where it goes. It goes to the left. See, it's moving to the left. So it's actually moving 2 units to the left. Should change the color of that puppy there. Let's change the color of that bad boy right there. Green. Sounds good. Okay, so as m gets larger, the graph moves to the left. So yes, that confirms what we had just said there. Now, what about x plus 2? Let's add something outside, and let's just see what that does. Where did our Desmos go? Okay, so I'm going to add here. Let's add p or something like that. So add another slider there. So as p gets larger, it goes up. As p gets smaller, it comes down. Now that looks like it's going left, doesn't it? But it's actually, that graph is kind of like going down. So our view looks like it's going left and right. But it's actually going up and down. Isn't that weird?
You just moved M, not P.
I did?
Yeah.
Oh, I am moving M. Sorry. Okay, so that's, okay. Well, that still looks like it kind of like is doing something different, but you're right. So this is going left, right. Okay, fine. And this is now going up. See there, it's going up. It looks like it's kind of stretching, but it's not. It's actually just going up. That's easier to see, up. See, up and down, up, down. You're right, I was grabbing M there, sorry. So M looks like this. I was like, what? Okay. So there you go. Okay, left, right, up, down, up, down. Okay? Transformations. All right, what else are we going to see in this lesson here? Ooh, evaluate without using a calculator. I love those questions. So awesome. Okay, what about e to the power of ln of 5? What's that?
Ln 5.
5.
Is it ln of 5 or is it 5?
It's ln 5.
50-50.
50-50?
No, it's 50. I'm putting my money
Okay, is it 5 or ln of 5, guys? What is it?
I'm putting my money on
Ln of 5, guys? Did you hear that? Is it 5 or ln of 5, guys?
I don't know.
I want a hamburger right now.
5 guys is
I
7.
don't know, 5 guys.
No, I'm putting my
Okay, what did the textbook say? What does the textbook say? Let's go back. All right, it's in our notes as well. Where is it? Where did I copy that from? Wow, this is taking forever. Oh my goodness, let's just go back to the notes. That's terrible.
It's 5.
Look at e to the ln of x is x. E to the ln of 5 is 5.
Yeah.
It's 5.
Hey.
I got it.
Gee, you got it. My foot. You got it wrong.
No,
All right.
Who said ln 5?
All right. So, it's not in 5, it's ln. No, you guys. All right. So, here's some questions for you to work on, like all these. Yay.
All of them.
Sure, why not? Do all of them.
No.
Doesn't that sound good, no?
For
Who said,
Hammond?
who said so?
You want me just to kind of like give you some important ones to work on?
Yeah.
Top luck. Okay. Okay, do the odd questions only. And then do the even questions.
Define.
It's Tuesday.
All right.
Realize John was in on the conversation, right?
John? I'm nobody.
Okay, guys.
Yeah, well, maybe
Guys.
the text
Shh. Quiet down, get to work, please.
Instructions, if you don't, just send Joe. I need a pen. Pen. She hit me on the head with a pen. She deserved it.